Welcome to the Crazy Hat Chemist. So another video on solutions, and boy do we have a solution here for you today. So let's get moving. Bam! So today is the Vent Hof Factor, and that is the I. Okay, so where is the I? And you should be familiar with this equation. That is delta T is equal to KIM. The delta T is the change in temperature of the boiling point or the freezing point. The K is the constant for either the boiling point or the freezing point. The I is the Vent Hof Factor, and that's what we're talking about today. The little m is the molality, and that is moles of solute per kilogram of solvent. So today we're talking about the Vent Hof Factor. Let's figure out what that is. The Vent Hof Factor, I, that is the ratio between the actual number of particles in solution after dissociation to the number of formula units. Okay, the Vent Hof Factor approaches a whole number, like 1, 2, 3, 4, etc., but it is generally less than the predicted whole number value. However, the whole number is a great prediction for an approximation for mathematical calculations. If you wanted an actual value, you would have to look in the Handbook of Chemistry and Physics and look in there and find the Vent Hof Factor that is in there for that particular formula unit. Okay, so hopefully you remember what a cation-anion combination is, giving you an ionic compound. And the cations, those are positively charged. That's the C there, that's positively charged. The anions, they are negatively charged. That's the A right there. Okay, so the cations always come first. The anions always come second, just like the symbol for California, the abbreviation for California. Now what we're trying to do here is we're trying to figure out the number of cations and the number of anions, and then we're going to sum those up. So that's what this little formula here is right here. We're going to obtain the Vent Hof Factor, which is I, and that's the sum of the number of cations and the number of anions. So we're going to do a number of examples here, and hopefully you will, by the end of this unit here, by the end of this lecture, you will get the Vent Hof Factor pretty simply. So we're going to write down a compound and the theoretical value of I. So I have a number of compounds of which we are going to do right here. So we're going to take a look at that first one. That first one is glucose. So that is C6H12O6. You should be familiar with that from your biology classes. So we're going to ask ourselves, first of all, is this an ionic compound? Okay, if it is an ionic compound, then it has a value of I that is greater than 1. Okay, glucose is a molecular compound. It is a molecule. It is not combined in a cation-anion fashion. And so therefore, when you take glucose and put it in water, it actually dissolves and does not dissociate. So that's why the Vent Hof Factor is equal to 1. So every 1 molecule of glucose, you get 1 molecule of glucose in solution. Okay, so glucose dissolves in water as opposed to dissociating. It is not a ionic compound. All right, let's look at the next one there, which is magnesium chloride. That is MgCl2. Magnesium chloride is an ionic compound. Excuse me, and it is composed of a cation-anion combination. The cation is the magnesium, the anion is the chloride. How many magnesiums do you see in this formula? 1. How many chlorides do you see in this formula? 2. You're going to sum those two numbers up. That is the number of cations, 1. The number of anions, that's 2. Sum those numbers up, that's 3. So the Vent Hof Factor here for magnesium chloride is actually 3 because it dissociates. That is, breaks apart into its cations and anions. That cation would be magnesium. The anions would be 2 chloride ions. Okay, the next one here is going to be KCl. That's potassium chloride. Okay, this is also an ionic compound and is composed of a cation, that's potassium, and an anion, chloride. There's 1 potassium, there's 1 chloride. I'm going to sum those two numbers up. That's a total of a 2. Okay, just so that you know, sodium chloride also have a Vent Hof Factor of 2, just like potassium chloride does, because it has 1 cation and 1 anion. The actual value of I, the Vent Hof Factor for sodium chloride, is like 1.9. So it's just slightly less than 2. Just like I'd mentioned before at the very beginning of this, it's a good approximation. All right, so the next one there is ammonium phosphate, and that's NH4 parentheses 3 PO4. So you're going to ask yourself, is this an ionic compound or a molecular compound? This is certainly an ionic compound. Okay, the ammonium ion is the only polyatomic cation that you're probably going to be dealing with here. So how many ammonium ions do you see there? I see 3 ammonium ions. Then I have the PO4, which is the phosphate ion. And how many phosphate ions do you see there? 1. So I'm going to add those two numbers up. That's the 3 plus the 4. That's the 3 cations, the 1 anion. And I'm going to get a total number of cations plus anions of 4. And that's why the Vent Hof factor is a 4. Again, this dissociates in water because it is a salt. It is an ionic compound. The next one here is Na2O, that is sodium oxide. Is this a molecular compound or an ionic compound? It is most certainly an ionic compound. Okay, and that is sodium. How many sodiums do you see in this formula? I see 2 sodiums in this formula. How many oxygens do you see in this formula? 1 oxygen. So, therefore, I'm going to add the number of sodium ions, that's 2, and the number of oxide ions, that's 1. That's a Vent Hof factor of 3. Okay, hopefully you're getting this pretty nicely here. Then the next formula here is C2H6O2. That's ethylene glycol. We've been dealing with that before here. And the Vent Hof factor for this, well, is this a molecular compound or an ionic compound? So we're asking the same question every single time. Because it has carbons, hydrogens, and oxygens, it's a molecular compound and it does not disassociate. It actually dissolves in water. So the Vent Hof factor here for any carbons, hydrogens, and oxygens is going to be a 1. Okay? All right, the next one there is sodium sulfate. And that is either an ionic compound or a molecular compound. Which one is it? It is an ionic compound. That is correct. So we have 2 sodium ions and 1 sulfate ion for a total of 3 ion particles here. So the Vent Hof factor is a 3. Again, I'm giving the approximations of the Vent Hof factor, not the actual. The next one there is ammonium nitrate. And this is this a molecular compound or an ionic compound? It is composed of a cation, that's the ammonium ion, and an anion, that's the nitrate ion. This is 2 polyatomic ions here. Okay, there's how many ammonium ions? 1 ammonium ion. How many nitrate ions? 1 nitrate ion. I'm going to sum those 2 ions up, and I'm going to get a value of 2. The Vent Hof factor for ammonium nitrate is 2. All right, the next one there is CO2, and that's carbon dioxide. Is this an ionic compound or a molecular compound? Now, carbon dioxide is a molecular compound. It is not composed of a cation and an anion. Okay, hopefully you remember your nomenclature from before, but it's carbon dioxide. That's a prefix naming. It has 2 nonmetals. That is most certainly a molecular compound. So the Vent Hof factor here for carbon dioxide is a 1 because it is a non-electrolyte. Okay, and in a future unit, we're going to be talking about electrolytes and non-electrolytes. Electrolytes conduct electricity in water, in solution, and non-electrolytes do not conduct electricity in water, in solution. Okay? All right, so I am the Crazy Hat Chemist, and I got a crazy hat here for you. Okay, here's a crazy hat, and paws up to you. If you like that video, give me a paw up. Subscribe to my YouTube channel. You know how to do that, hopefully. Go to the YouTube thing and subscribe to my YouTube channel. Pass this on to all your cool chemistry friends and tell them a hi paw.